Hello viewers, welcome back. So in the previous video, we have seen the basic concepts and definitions related to finite state machines, finite automata, or in short, theory of computation. Well, in this video, I'm going to discuss about what are the various languages you are going to learn in this subject, what are the various machines involved with those languages, that is, कौन से वो machine है जो उन languages को accept करते हैं, what is the power of those machines, which machine is stronger, which machine is weaker, स्ट्रॉन्गर एंड वीकर एज इन कौन से मशीन से कौन से इनपुट्स एक्सेप्ट हो सकते हैं, कौन सा ऐसा मशीन है जो सबसे पावरफुल है. विल लर्न अबाउट दैट इन डिटेल इन दिस पर्टिकुलर वीडियो, फॉलोड बाय what are the various types of automata. Okay, so we'll learn the classification of automata, what exactly finite automata is, before we actually begin with solving problems on finite automata. Okay, so the very first concept is what are the types of languages. Languages, according to the syllabus which is being referred by all the competitive exams or university exams or university syllabus, they are having these four types of languages, or in short, these are the four languages which are there in theory of computation or automata theory. The very first language is what we call as a regular language. Now, regular language is nothing but a language which is accepted by a machine called as finite automata. So in short, just imagine that you are a native English speaker and you know what English is. You can converse very easily in English. But when you step into a different country where the language or the primary language is not English, then you need to have a translator or you need to learn about that particular language, right? So we need different machines to accept different languages. Over here, in this case, the very first language is what we call as a regular language. We'll see exactly what is a regular language whenever we will start with the particular concept. But for the time being, for simplicity, regular language is simply a language very much similar to English, Hindi, Bengali, etc. So it is one of those languages which needs a translator or which needs a machine called as finite automata. So if you are having knowledge of finite automata, then you will be able to understand what a regular language is. Similarly, there is one more language called as context-free language. For a context-free language, knowledge of only finite automata will not be sufficient. You need something called as a push-down automata to accept certain languages which are called as context-free languages. So for example, you have now moved to China and you want to communicate with the native Chinese speakers over there. But it is possible that the fellow in front of you is not able to understand your English. So there is only one possibility: either you hire a translator or you learn Chinese language. So in this case, that push-down automata is nothing but the Chinese language. So you have to learn that language, and if you are able to learn that language, so in this case, push-down automata is nothing but that Chinese language. Or you can say that machine or the translator which will translate your English into Chinese and vice versa. So the same principle goes over here. Context-free language is nothing but the language you want to learn, and for understanding that language, you need a machine called as push-down automata. On the similar grounds, there is one more machine called as linear bounded automata, which will accept only context-sensitive languages. So if you are having context-sensitive languages, you need a machine called as LBA or linear bounded automata. And finally, there is this language called as recursively enumerable language, for which you need a machine called as Turing machines. So these are nothing but the four machines which are of utmost importance. You must understand and learn all these four machines and the problems associated with these machines. In the exams, you will be asked questions based on PDA, finite automata, Turing machines, LBA, and you should be in a position to solve those problems. सबसे ज़्यादा scoring इनमें से PDA, Turing machines के questions होते हैं, so you have to be aware of how to solve such a problems based on these machines. Right? So we'll learn in detail in the next few videos. At this point of time, I'm simply discussing what are the various types of languages and what is their power. So let me show you one concept called as Chomsky's hierarchy. Chomsky's hierarchy is nothing but a very beautiful visualization which enables you to understand which sort of a language is accepted by which sort of a machine and what is their power in terms of acceptance or in terms of solvability. Right? So if I take example of a finite automata, you can see that finite automata is nothing but used to accept type 3 languages, that is nothing but regular language. So let me write it over here. A type 3 language people make mistake over here. They start with the innermost circle as type 0. No, the innermost circle is nothing but type 3. Okay, so let me write it over here. Type 3 is nothing but regular languages, whereas it is accepted by a machine called as finite automata. Similarly, if we move out of it, we'll see there is this type 2 machine or type 2 language, which is nothing but a context free language, and we already know it is accepted by a machine called as PDA. Similarly, if we go one step ahead, there is this next layer called T1, that is type 1, and it is nothing but context sensitive languages, and it is accepted by linear bounded automata. If I go one step ahead, final step, there is this particular type 0, which is nothing but recursively enumerable languages. It is accepted by a machine called as Turing machine. So now if I talk in terms of power, I can say that T0 over here is more powerful as compared to T1, which in turn is more powerful as compared to T2, and which in turn is more powerful as compared to T3. So if I write it like this, Turing machine is the most powerful machine which will accept almost all type of inputs, all type of strings. So this particular question comes for approximately 5 to 10 marks if I'm talking about university exams, or a similar question could be asked in the competitive exams also based on the power of such machines. So I hope you understood this particular concept. Let's move on to the last part of this particular video, that is the classification of finite state machines. From here we are going to start our first module in detail. That is what exactly is finite state machine, finite automata, and what is its classification. Finite automata in essence is divided into two parts. First is finite automata without output and finite automata with output. So whenever I am talking about finite automata without output, it doesn't mean that I am not going to get any output at all. It simply means my main focus is going to be on the transitions rather than on the outputs. On the other hand, whenever I'm talking about finite automata with output, my main focus is going to be the outputs only. Let me take a very simple example. If you want to design a calculator, okay, for example 2 plus 3, I know 2 plus 3 should be 5. So my main criteria is I should get the output as 5. I am not bothered with how I obtained 2 plus 3. Whereas on the other hand, finite automata without output is going to focus on how I got this 2 plus 3. Is it 1 plus 1 plus 1 plus 1 plus 1, or is it 1 plus 4, or is it 2, or is it 2 plus 2 plus 1, or something like that, right? So this is what is the basic difference between finite automata without output and finite automata with output. So I can further divide the FA without output into these many classifications, that is DFA, then NFA, and then epsilon NFA. We'll discuss about that much in detail in the next. So we'll discuss about all these machines in much detail in the next few videos. So for the time being, these are the 5 different machines which we are going to understand in our very first module, that is finite automata. Next up, we are also going to learn about what is FA and FSM. So I'm leaving this for the next video. So stay tuned and do subscribe to my channel for the next upcoming videos on this particular topic of theory of computation. Thank you so much.